Welcome back. This is April 15th and 16th lesson. We have seen this graph before. This is the one I gave you a note on, but the graph of a quadratic function can look like this. We have key features. We have the vertex, which the axis of symmetry actually goes through. We have y-intercepts, and we have x-intercepts sometimes. So you do have notes on this, you do a workout, and just to remind you that these are our 5 key features that we're going to be focusing on with quadratics. Okay, so this leads us into the objective of the lesson. The graph of a quadratic function has 2 distinct shapes. It's either a right side up U shape with a minimum, like this, which we just saw in the lesson before this, or an upside down U shape with a maximum point, like so. I like to say, personally, I talk a lot about parabolas that are have minimum points or maximums. The book sometimes talks about upside down U or right side up U. As long as you realize like a minimum has a U shape and a maximum has like an upside down U shape. So those are the key features. Now we have 2 shapes. We have the minimum ones and we have the maximum shaped parabolas. So our objective today is that how can you know ahead of time if a quadratic function will have a maximum or minimum point by just looking at its equation, right? And that's our goal. We're kind of sort of moving away from having to graph to know whether a parabola will have all the key features. We can actually find them without graphing, which is cool because graphing takes a while. So our goal today is being able to figure out how to know ahead of time if a quadratic's equation, when we graph it, when we make a graph of it, its function, will have a maximum or minimum. Okay? So I wanted you to explore it. So again, so our goal is how can we determine if a quadratic function has a maximum or minimum? And I threw it in there as well. Can you know its y-intercept from the equation? Okay, so it's double part. I'm gonna have you graph 4 functions, which if you have the worksheet, that's what it is. Make a table for each, graph each, and then identifying the key features, right? And then you should be able to tell, look, which ones have maximum and which ones have minimums. And the y-intercept. If you look at the equations and the y-intercepts, you should be able to figure that out. If you look at the functions, equations, and we look at the graph, we should be able to figure out something. Okay? So that's what I wanted to go through. I did the first one for you. So if you want to write it down, this is f of x equals x squared plus 5. This over here is just the notation for the numbers that I want you to plug in for x in your table. From -2 to 2, I want you to use the whole numbers. So you can see down here in my graph, -2, -1, 0, 1, 2. Okay. When you plug -2 in, you get 9. When you plug -1 into our function, you get 6. You put 0 and you get 5, 1, 6, 2, 9. The vertex happens at 0, 5. It's a minimum, so this function got us a minimum. The y-intercept for this parabola is 0, 5. That's weird, same. And the equation for the axis of symmetry, you know, here's our axis of symmetry. Let me draw it in, actually. Here's our axis of symmetry right there, because it goes through the vertex right there. I don't know if green made the most sense. Hold on, let me. Much better. Okay, so our axis of symmetry, which goes through the x coordinate of 0. Whoop. So there it is. Okay. Now would be a great time for you to pause this video and go ahead and do the second, third, and fourth one on your own. if you just want to copy the table and all the key features, you could do that as well. You could block it out. For now, I'm going to keep going, but this is a spoiler alert. So if you want to do 2, 3, and 4, you can, and then answer questions. I'm going to continue on with this video and show you the answers for the next couple. Okay? So and you have this. This is a handout that's part of the work I uploaded for this lesson. Okay, here's the next one. A little bit tricky, but again, this is our function. I want you to plug x values in that are from -3 to 1. And here it is on my table. -3, -2, -1, 0, 1. If you're using a calculator, that might help you here, but you get -1, 0, 3, 0, -9. That goes with these x's. You plot it, and you get, you get a maximum one, right? I wanted you to label the key features. So here's your vertex right here, right? It is a maximum. The other one was a minimum. That's interesting. The Y-intercept is here at 0, 0. And the axis of symmetry, again, goes through the vertex. So that happens at -1. Cool. Go to the next one. I want you to do the numbers from -4 to 0. Whole numbers, so not whole numbers, sorry, integers. -4, -3, -2, -1, 0. When you plug them in, you get 4, 1, 0, 1, 4. And here's a shape of your graph right here. The vertex is down here, right there, boom. It's another minimum. That's interesting. Y-intercept over here, we're trying to discover what's going on with the Y-intercept. It's right there. And the axis of symmetry, psh, 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 boom, there it is, x equals -2. Right? And the last one I wanted you to do for your explanation, I wanted you to use the numbers from 0 to 4, plug them in. Here you go. And those are what you get when you plug in these 5 values. And again, we got that quadratic. Okay, here's our vertex, bing. A maximum. Our Y-intercept is -4, whoop, not 5, -4, and maybe you're starting to get good at the axis of symmetry. There it is at x equals 2. Cool. So now we're just going to look back and think about how can we decide if it's going to be a minimum or maximum. Okay? Just by looking at the function and looking at its equation. So here we go. Here's number 1, here's number 3. They both have minimums. They both have minimums. These both have maximums, right? So can you just look, right, at the function to know that it's going to have a minimum versus a maximum? And I would make you think about it. And I would say, hey, talk to your neighbor, see if you can figure it out, right? Well, these equations are very different, these two, right? But they both have minimums, right? They're both U-shapes. What's the same about them? These two both have maximums, right? But they are also very different from each other. But these two have something in common, and these two have something in common, which makes them different than these two, right? Talk about it with yourself or whatever. See if you can figure it out. Okay, take a look at this. That's a plain old x squared. That's a plain old x squared. This is a -3x squared. This is a -x squared. So maybe now you see, or maybe you knew ahead of time. But take a look. Positive x squareds, minimum. Negative x squareds, or the a value, which we'll talk more about in a second. Right? Whoa, the negatives give you a maximum. That's weird. And the positive give you a minimum. All right, let's return. So, how can you identify whether or not a function has a minimum or maximum? This is the notes you would take. If the coefficient of x squared is positive, minimum. If the coefficient of x squared is negative, it's a maximum. That's what we just kind of noticed. Now, there's a way to do it with more of a math vocabulary, which I did right here. We talked about this last week. Quadratics have a standard form of f of x equals ax squared plus bx plus c. So if a is greater than 0, right, positive, minimum. If the a value is less than 0, maximum. So positive a values, minimums. Negative a values, maximum. Kind of flip-flops, right? Cool. All right, 7. I'm going to keep going. Maybe you want to pause and think about it and take a look at the y-intercepts. I'm going to do that. Okay, how can you identify the y-intercept by just looking at the equation of the function? Well, this is what I would do in class, so I'm going to just do it. Let's see. Take a look at this function. Look at the y. Oh, gosh, shoot. Let me go back. Take a look at, I don't like that light blue. Let's change that up. Go back to magenta. Look at that. Oh, what the heck? It's frustrating. Well, just look at this and look at this, right? Look at the function, x squared plus 5. Look at the y-intercept. X squared plus 4x plus 4. Look at the y-intercept, 0, 4. Negative x squared plus 4x minus 4. Look at the y-intercept. Negative 3x squared minus 6x. Look at the y-intercept. Equation, y-intercept. Equation, y-intercept. Equation, y-intercept. Equation, y-intercept. So is there a way to know the y-intercept before you do it? Oh, okay. Yeah, you can, right? The c is the y value of the y-intercept. So in standard form, it's that n term, the c, that has no variable next to it. That's the y-intercept. What if there is no constant, like the one we had? Well, then the y-intercept has to be 0, plus 0. Here are the answers to part 8, right here. I would pause it now because I just got a call that I have to pick up. And then there's an exit ticket. You now know some of the key features of this one, and that's it for the lesson. Okay. Hey, what's up? Oh, shoot. I forgot to cancel this video. Shoot. No. Command Shift 5.